efficiency and environmental well-being, electric mobility is being mooted. Okay, so first of all,
হ্যাঁ স্যার, আপনি আমাদের ইউনিভার্সিটি নেটওয়ার্কে জয়েন করছেন তো স্যার? ও কিন্তু স্যার আমার তো এখানে যেন আমি তো ফার্স্ট ফ্লোরে বসে আছি, আমার তো স্যার মোটামুটি ঠিকই হচ্ছে আর কি। আমি আমার ল্যাপটপটা নিয়ে যাবো স্যার। হ্যাঁ বলছি স্যারকে বলো আমি আমার ল্যাপটপটা নিয়ে যাবো স্যারের ঘরে তাহলে। আচ্ছা ঠিক আছে। আচ্ছা ঠিক আছে, ঠিক ঠিক আছে, ঠিক। উফ, হয়েছে তাহলে এই মেশিনটা নিন না স্যার, এই মেশিনটা। হঠাৎ দিনে তোমার সাথে আপনার দঙ্গল কেন না বাবা এটা পেন ড্রাইভ আছে তো স্যার আপনার? হ্যাঁ মেলে আছে স্যার, মেল থেকে ডাইরেক্ট করবো। আচ্ছা মেল দিয়ে রাখবো সেটা। তাহলে আমি আমার মেল আইডিটা আপনার কোন মেল আইডি দিবেন স্যার? আপনি আমি আমার যাদবপুরের আপনি স্যার আমাকে আপনারা পাঠিয়ে দিন না স্যার, ওটা পাঠিয়ে দিন আমাকে মেলে, তাহলে আমি ডাউনলোড করে এক্ষুনি তাহলে করে দিচ্ছি। সেটাই হবে সুবিধা। হ্যাঁ এতটা ভিকিট দিয়ে কানেক্ট করা যায় তো? হ্যাঁ হ্যাঁ, ওই লেখালেখির জন্য তো। হ্যাঁ এটা তো স্যার যেগুলো জানেন। আজকে সকালবেলা স্যার প্রবলেম হয়েছে, ব্যাঙ্গালোরের প্রফেসর খুব গালাগাল দিয়েছে আমাকে। হ্যাঁ ওই ভিউয়ার হিসেবে ঢুকে যাচ্ছে, এই হচ্ছে, কাউ কিছু করতে অ্যাক্সেস করা যাচ্ছে না। তুই ওকে ডাক, ওই লোকটাকে ডেকে ডাক তো। হ্যাঁ ওই লোকটাকে ডাকতে হবে, খুব ঝামেলার জিনিস। একটা জিনিস দেখতো ওখানে টিউবলাইট গুলো বন্ধ করে, মিটার কাটার টিউবলাইট খোলা থাকে, তার চোখ অন অফ করে এবং তারপরে ওই ঘটনা ঘটে। এই না ওইখানে এই যে মাইক
Well, am I audible now? Hello?
Yes, sir. Yes, sir. Audible.
Okay. So, okay. So as I was just saying
Well,
that
Adi.
thanks to Dr. Tudu, I could get into the network, and I hope it is going to work for some more time. So whatever it is, so this is the. So as I was just telling you that electric mobility is required for a number of reasons. Okay. So ultimately, the reduction of carbon footprint it's a bigger chain, but we are going to restrict ourselves to the cleaner aspect of mobility. And then how do we use AI? As technology emerges, it comes with new challenges. There are many, but some of the important are as follows. First of all, charging of the battery, charging infrastructure, cost of battery renewal, and fault tolerance. Now, when I'm talking about charging infrastructure, it is often very important for us to actually also think of the different kinds of options that we have. As you know that one of the most important system is of course the complete BEV, that is the battery electric vehicle, which we are going to discuss today. The other is PHEV, which is basically plug-in and hybrid electric vehicle, in which you have an engine and also the ICE and also a motor. And then the switching between ICE, the motor can be charged directly, and the ICE can be fueled by fossil fuels. And there is an automatic changeover from a motor to the IC whenever required. The later version, a hybrid electric vehicle, where you don't have the charging port to charge the motor directly. It is the internal combustion engine which charges the motor, which charges the battery, and then drives the motor. And then there is also charging through regenerative braking. And finally, we have the fully electric, which is the BEV, or the battery electric vehicle, which is what we are going to consider today. Now, this is the anatomy of an electric vehicle. As you can see over here, the electric vehicle has a basic traction motor. Okay. Now, this is a non-conventional type. Usually, the traction motor comes with a traction battery pack and also with an auxiliary battery pack. The auxiliary battery pack powers the other systems. The traction motor powers the traction. Now, this is an old concept, and this concept is no longer much of use over here. Now, what we now try to do is basically, we try to, if you take a look over here, you will see that there are several features associated with it. And electric motor, as you can see over here, and this motor is being run by a battery. This is the battery pack, as I've shown you. This is the total battery pack. Now, this battery pack must be placed. This is placed, as you can see over here, on the floor, so that the CG of the car doesn't get disturbed. Now, there are other models where you can split the battery pack also in the boot, and then the boot space goes, and you can also put it over here. But then the idea is that you cannot put it in the trunk or in the front because the CG will be disturbed. The CG must be towards the center of this, and it should be as low as possible. So the toppling moment is less. Now we also have a thermal system. These batteries require some kind of a cooling, so they require a thermal system to cool these batteries. And then we also have a power electronic controller. Now, in most cases, the EVs they don't operate on they operate on a lock gear ratio. Okay, so basically you don't need a gear because you can control the motor speed and the motor torque, and with that you can control the entire kinematics of the EV. So you don't need a gear. So they have operate on a lock gear ratio, which causes a lot of problem and makes the motor much bigger. So now if you use a motor with a different voltage rating and then with the DC, you also require a power electronic bulk controller. This is called the motor control unit, and this controls the motor to drive the motor at different speeds altogether and distribute the battery current. Then you can see that they also have a charging port, and the transmission system is actually a direct coupling system. So the motor can be in line with the differential not disturbed over here, or the motor can also be a normal one with a drive shaft coupled. Normally, we prefer an inline motor, and then depending upon this, we can have the four-wheel steered drives or the four-wheel steered and four-wheel control drives altogether. That's fully automatic EV. And you also have an onboard charger and the battery, which is an auxiliary battery for charging for the actual system, so that if the battery goes down, so you can still have some of the features of the car. Many times you'll find that an EV gets stranded and then you cannot move, so you will have to have some features which are on. So this is for emergency purpose. And interesting thing about the charger is that the charger could be, this is the charger over here, as I showed you over here, the charging port. So I think the charging port is somewhere over here. As you can see, the charging port. The charging port is used for charging the battery, and then with the charging port, you also have an onboard charger, which is for different purpose, of course. That is for often for regenerative braking and all that. So you can use AC charging. If you use AC charging as it is shown over here, the AC charging is going to make it run much faster. And you can also have a DC charging. The AC charging port is a slower. And you also have a DC charging option where the charging is much faster. But the AC charging is mostly used and it's very cheap. You can do it overnight at home also. Now I have to talk a little bit about the cow because it's about the cow and the burning heart. And the cow, I don't know which one is the cow and which one is the burning heart over here. So basically, it's the digital twin that I'm going to talk about. And what are digital twins? Digital twins are real-time digital models that allow for self-diagnosis, self-optimization, and self-configuration with the need of human input or intervention. So basically, a twin. So basically, it is a simulation, in short, of a system or an asset that actually copies the behavior of the system or the asset for a long time. Okay, so just as the twin ages, the asset ages, the twin ages. Okay, so we must say uh, DT. Okay, the DT ages with the system, which means let's say that you have a system and you have a digital twin, and today the system's parameters are something, so day after tomorrow the system's parameters may not be the same thing. It may be something else, but then the gain of the controller will automatically change. It will learn from the behavior and it will automatically change itself to order the. So basically, so let's say you have a mechanical system. So with age, what will happen? The mechanical system's friction, etc., will change. These parameters, the spring constant, etc., will change, and the force that you have required originally to move this system would not be the same as the force required again. So you have to actually change that. And if you have to change that, then you need to actually change the system, retune the system, right? So the controller again has to be changed. The control parameters have to be changed, but you don't need to do that if you use a digital twin, because the digital twin is going to mimic the age of the system also, and it's going to do that. So definitely, you cannot really build a digital twin for every possible asset, and if we do it only for some critical assets, and now the origin of the word digital twin concept is from the Apollo 13 mission. Okay, so this Apollo 13 mission was actually a grand wise simulator. So what happened is this, that the NASA engineers developed a digital twin, or actually a very precise simulation of the Apollo 13 spacecraft. And after 2 days of flight, the tank number two blew up, causing there were two oxygen tank failures. The command module supplied electricity, light, and water was lost, and they were about 2 lakh miles from the Earth. NASA used the first ever digital twin to find a solution. So that was a simulation where they could actually plug in the actual conditions and find out what are the values, because that was mimicking the behavior totally. And this actually led to a very new concept of simulation, which is called data-driven simulation, and which uses a substantial portion of AI, and which is also a part of the digital twin technology. So, depending upon the twins could be of different types. It could be a component twin, where you have the twins and the parts. It could be a component twin. As I told you, component twins are those. A single component, name suggests this is the twin for a single component in the entire system. There could be asset twins. Asset twins are the next higher level of the digital twins. They describe how. So, in the car's case, if I have a battery and the BMS, and I want to see how the battery is charged, how the battery ages. So I would build a battery's digital twin, which will be the digital twin for a component. It could be an asset.